Okay, students, I'm going to be passing back the test today.
Oh no. Yes, I'm sure I got 100.
Well, you better change your mind. These are the worst test grades of the year.
What, the chicken nugget? I got a 42? How? I'm sure you have to have graded this incorrectly. There's no way I got a 42.
Stupid chicken! Being extremely low, I will require all students who received a grade lower than a 70 to attend tutorials after school today. And yes, that's all of you.
Man, this can't be happening. I thought ionic bonding was easy.
I knew this test was going to be hard.
I mean, it makes no sense. If I'd studied, I could have done better. Yeah. I really hope at least this tutorial makes sense. I mean, I'm not really looking forward to spending another hour in school just learning absolutely nothing.
Alright class, we all know why you're here. Let's get down to business. Okay. Okay, did you guys get all of that? Seems not. I guess I'll have to explain this to you guys in another way that you two stupid chickens would understand.
Where are we?
What is all this stuff?
What are we doing?
Why are we wearing proper lab attire?
So I had to pull out all the stops to get through your thick heads. And we always wear proper lab attire. So what do you guys remember, or what do you guys think you know about the properties of ionic bonding and ionic compounds?
The electrons are delocalized, which is why they are ductile, malleable, and good conductors of heat and electricity.
I'm pretty sure it's between two metals or cations, right?
Ionic compounds have a high bonding point, but a low melting point.
They're lustrous and very hard, but due to their high density. See, we know what we're talking about. How did we fail that test?
You two are really hopeless, aren't you? You just listed the properties of metallic bonding, not ionic bonding. Although I guess I can give it to you that you did at least know something out of this unit.
What the?
Alright, we're gonna have to start from the top. Ionic bonds are formed when cations, metals, and anions, nonmetals, are bonded together. Electrons are not shared. I'm looking at you, Floor. Electrons are transferred.
Okay, I'm going to share this telepathically.
Okay, so this is table salt. And this is the crystalline structure of table salt. And this is the crystal lattice. So you can see these alternating sodium and chlorine atoms. And this is what ionic compounds look like. So they're very brittle. The ionic compounds are extremely brittle. And they have a very high melting and boiling point. And they're very solid at room temperature. Additionally, when they do get to a molten state or even an aqueous state, they conduct electricity very well.
Oh, I think I get it now.
Finally, it took you so long.
Shut up. You got a worse grade than me.
Whatever, we both failed the test anyway.
Okay, now you guys must demonstrate that you know how an ionic bond is formed. Prove to me that you can actually retain information in those maimed heads of yours?
Well, remember, she told us that the magnesium atom transfers an electron to the fluorine atoms, allowing the atom to be stable by meeting the octet rule.
Now you're getting it. Let's get to naming.
Yo, where's that marker at? Okay, so we're starting at the top, right? So, kids, pay close attention, because this is very important, and you would have known about this if you actually got a good grade on your test. So, what we're going to be learning about today is nomenclature. So the first step in nomenclature is to know the oxidation number of your elements. So what elements we have here today is magnesium and fluorine. So what we're going to be doing is trying to combine those two into an ionic compound. So first what you're going to do is know the oxidation number, which is +2 and -1. And from here we're going to be crisscrossing them, like this.
So the oxidation number of magnesium becomes the number of atoms for fluorine?
Correct.
So there would be 2 fluorine atoms and 1 magnesium atom?
That is also correct. So the last step is to put them together, and like this.
So the formula is MgF2 and it's called magnesium fluorine?
Almost. So the thing is that when writing the name of a formula, you always put the metal first, like you did. But the ending of the non-metal changes, but the metal doesn't change. So it would be magnesium, but instead of doing fluorine, we would take out the INE and change it to an IDE, like so. So this is different with polyatomic ions. So, however, with polyatomic ions, bonding with metals, the ending of the polyatomic ion does not change. For example, take magnesium and nitrate. So there's magnesium and nitrate. So what we're going to do here, so magnesium and nitrate, when they bond, they make the oxidation number flip-flops over here. So when bonding these two, it's going to be magnesium nitrate, and it's going to keep the ending, and in the formula, it's going to be NO3, and then 2. So there's going to be 1 magnesium and 2 nitrates. There's another exception though. Can anybody tell me how to say can you tell me what the name of this is?
That'd be iron carbonate, right?
No, that's very close though. It would actually be iron 3 carbonate. Like that. And the reason for that is because we need to add the Roman numerals. These are really important because for whenever you have a transition metal such as iron, you need to have your Roman numerals in order to tell what type of phase it's in or which state it's transitioning between. Therefore, you must write the Roman numeral right here between the metal and the non-metal to indicate what the oxidation number is for the metal. And with that extra lecture, you guys should have gotten everything you need to know for the test. Good luck. Okay guys, today you guys are going to be taking the retest for the ionic bonding test that you guys both got 42s on somehow. So, if you don't ace this test, then I will personally come to your house and personally lecture you for 7 hours straight.
God. We would erase this test, so she's gonna tip Lana.
You may start the test. Congratulations, you guys both got 100 surprise me. Here.
Wow, it's all thanks to your lecture. Thanks, Teach.